Hello and welcome to another South Korean College Scholastic Ability Test video. Today we will solve the following problem. fx is a function continuous for all real numbers satisfying following conditions. Condition A, fx equals a times x minus b squared plus c when x is less than or equal to b, where a, b, and c are constants. Condition B, fx equals integral from 0 to x square root of 4 minus 2 ft dt for all real numbers x. Then integral of fx from 0 to 6 equals q over p, where p and q are coprime natural numbers. Find p plus q. Right, so first, this entire p and q thing is just to make the answer a natural number from 0 to 999. So this problem is essentially asking you to find this function fx. So the first thing to tackle is this condition B, where we basically have function fx defined using a definite integral with x in the upper bound. Now, if you have this type of equation, there are two things you can do. First, you can substitute x equals k to obtain a condition fk equals 0. And next, you can differentiate both sides. Then, by the fundamental theorem of calculus, we obtain f prime x equals simply gx. So we are going to do these two things in given condition B. So first, set x equals 0. Then we obtain f0 equals 0. Right, so we have obtained one condition. Next, we differentiate both sides. Then we obtain f prime x, the derivative, equals square root of 4 minus 2 fx for all real numbers x. So now we have some sort of radical differential equation. You see, there are some important things to remember when you're dealing with radical equations, but I will explain them a bit later when they become relevant. For now, I really don't want to see this radical symbol, so let us remove it by squaring both sides. Then we obtain f prime x squared equals 4 minus 2 fx. Note that since condition B holds for all real numbers x, this equation also holds for all real numbers x. That is, this equation is valid when x is less than or equal to b, which was the domain given in condition A. In that domain, fx is given as a quadratic function ax minus b squared plus c. So we can substitute this into this equation. The derivative is 2a x minus b. So from here, we have 4a squared x minus b squared equals 4 minus 2fx, so 2a x minus b squared minus 2c. You know, in this domain. Now let us rearrange the terms. So we have x minus b squared here and x minus b squared here. So if we move this part to the left-hand side, we have 4a squared plus 2a x minus b squared. And if we move this and this to the left-hand side also, then we have plus 2c minus 4 equals 0. And we can divide both sides with 2. Then we have 2a squared plus a x minus b squared plus c minus 2 equals 0. So here we have a times 2a plus 1. And if we expand this, we have x squared minus 2bx plus b squared. Then we have plus c minus 2 equals 0. So if we write in decreasing degree of x, we have a 2a plus 1 x squared minus 2a plus 1b x. And the constant terms are plus a 2a plus 1 b squared plus c minus 2 equals 0. And notice that this identity holds for all values of x in this domain. And the only possible way is that every coefficient on the left-hand side, including constant term, must be 0. So we have a 2a plus 1 equals 0, and a 2a plus 1 times b equals 0. And for the constant term, a 2a plus 1 b squared plus c minus 2 equals 0. From the first one, the coefficient of x squared, we have a equals 0 or a equals minus 1 over 2. So which is the valid one? Well, we have to check. So the first case, when a equals 0, then from the coefficient of the constant term, this entire part becomes 0. So we have c minus 2 equals 0, therefore c equals 2. So the values of a and c are determined. Then from here, since a is 0, this entire part becomes 0. Therefore we have fx equals c, which is 2, when x is less than or equal to b. However, the problem occurs if we think about the condition f0 equals 0, which we have previously obtained, plus this derivative condition, which we have also previously obtained. You see, fx equals 2 when x is less than or equal to b, so even though we don't know the exact value of b yet, we know that if x is sufficiently negative, then the value of fx will be 2. But fx also passes 0, 0. You see this point. Since fx is given as a continuous function, this means that fx has to decrease somewhere in the region where x is negative. But this condition indicates that derivative f prime x is non-negative for all real numbers x, because square root of something like this is always non-negative. Therefore, since the derivative is always non-negative, fx cannot decrease anywhere, so there is no way to construct a continuous function fx in this case. Therefore, it is an invalid case. A cannot be 0. So we move on to the next case. Case 2, when a equals minus 1/2. Similarly, from the coefficient of the constant term, now this part becomes 0, so we still have c minus 2 equals 0, therefore c equals 2. So we have values of a and c. And we have fx equals minus 1/2 x minus b squared plus 2 when x is less than or equal to b. This is a concave parabola with x equals b as the axis of symmetry and point b, 2 as a vertex, but only the left half of the parabola because the function is only defined in this domain. And here, the value of this b is still undetermined. Therefore, just like the previous case, we turn to the derivative and radical conditions and think about the entire graph of fx. First, I have already explained that the derivative of fx is non-negative, hence fx cannot decrease. Using this information, we can determine the sign of b, which means whether b is positive or negative. First, let us consider a case where b is negative. Then when x is less than or equal to b, the graph of fx is given as this parabola, where this b is on the negative x side. But we have already obtained that f0 must be 0, so the graph must pass this point, 0, 0. And since fx is a continuous function, this means that fx must decrease from 2 to 0 somewhere around here, which we all know that it is impossible due to this derivative condition. Therefore, b cannot be negative, so b must be positive, or at least non-negative. So we have these conditions, and now the graph might look something like this, at least when x is less than or equal to b. So b is on the positive side, and now we can make good use of this f0 equals 0 condition, because now the parabola has to pass the point 0, 0, which means we can use this equation of parabola for this condition. Therefore, we have minus 1/2 b squared plus 2 equals 0. So we have b squared equals 4, and b cannot be negative, so we take positive value b equals 2. And there we have the value of b. So fx is given as this when x is less than or equal to 2. And now we have to find the expression for fx when x is greater than 2. And for that, we return to this radical functional equation. I have already used f prime x being non-negative condition, but that's not the only condition we can extract from here. You see, for a radical equation a equals square root of b, there are two hidden conditions. First, the square root of something cannot be negative, so we have a, which is square root of b, must be non-negative. Second, the inside of the radical sign also must be non-negative, So we have the condition b is non-negative. So this first condition gives f prime x non-negative. And for this second condition, we have 4 minus 2 fx is greater than or equal to 0. So the combined conditions are, first this, derivative is non-negative, and second condition is fx is less than or equal to 2 for all real numbers x. Now let's get back to the graph. The function reaches value 2 at x equals 2, but the function cannot exceed 2. Also, due to the derivative condition, the function cannot decrease anywhere. Therefore, the only choice left is that fx must be a constant function fx equals 2 when x is greater than 2. So we have this complete graph. Therefore, we have obtained the entire fx, which is this. And the problem asks us to calculate integral from 0 to 6 fx dx. So first, from 0 to 2, we have this function, and from 2 to 6, we have constant function 2. So here we have minus 1/2 x squared plus 2x and 2. So if we integrate, we have minus 1 over 6 x cubed plus x squared. And for the second integral, we don't even have to integrate it. It's just 2 times 4, right? So if we calculate this, we obtain 32 over 3, and this is equal to q over p. And since p and q are co-prime natural numbers, we have p equals 3 and q equals 32. Therefore, p plus q is 35. And this is the answer. So this was a really nice calculus problem, also combined with some sort of radical equations, where you have to think about the non-negative conditions related to radicals. If you enjoyed this video, please hit that like and subscribe buttons, and as always, I will see you in another video.